Welcome back to my story corner. My name is Jess. This channel is usually where we explore the creepy, the unexplained, and the stories that make you stop and think twice. But right now, real science is doing something just as unsettling and honestly just as fascinating. Because today, history was made. For the very first time ever, scientists have detected X-rays coming from an interstellar comet. And that comet is 3I Atlas. Let's talk about what was discovered, why it matters, and why tomorrow's data could be even bigger. Thanks for being here with me today. Before we get into it, if you haven't subscribed yet, now's the time. We're tracking every update on 3I Atlas as it happens, and things are moving fast. Real fast. Alright, so here's what happened up till now. Between January 26th and January 28th, 2025, Japan's space agency JAXA aimed their powerful X-ray telescope at 3I Atlas. The telescope is called XRISM, and unlike normal telescopes, it doesn't look at visible light. It looks for X-rays, which come from very energetic interactions in space. XRISM watched this comet for 17 straight hours. And what it found surprised everyone. Surrounding 3I Atlas was a faint but very real X-ray glow. Not small, not subtle. This glowing cloud stretches roughly 400,000 kilometers, or about 250,000 miles, around the comet. To put that in perspective, that's about the distance from the Earth to the Moon. This matters because scientists have tried this before. When Oumuamua passed through our solar system in 2017, they searched for X-rays. They found nothing. When Borisov followed in 2019, they tried again. Still nothing. 3I Atlas is the first interstellar object ever confirmed to emit X-rays. Harvard astrophysicist Dr. Avi Loeb wrote about this discovery, explaining that until now, 3I Atlas had only been seen in visible light, ultraviolet, infrared, and radio waves. X-rays were missing. Until now. So, why is this such a big deal? Because X-rays show scientists things normal light can't. They reveal how the comet interacts with the solar wind, and they give clues about the chemistry and structure of the gas surrounding it. So, how does a comet make X-rays? Here's the simple explanation. Comets are icy, dirty snowballs. When they move closer to the sun, their ice heats up and turns into gas. That gas forms a large cloud around the comet called a coma. At the same time, the sun constantly blasts out the solar wind, a stream of charged particles flying through space at incredible speeds. When those charged particles slam into the neutral gas atoms in the comet's coma, electrons get stripped away. When those electrons snap back into place, energy is released. That energy comes out as X-rays. This process is called charge exchange. Scientists first discovered it in 1996 while observing a comet from our own solar system called Hyakutake. Since then, they've seen it in dozens of local comets. But never before in a comet that came from another star system. So, why wasn't this detected earlier? Timing. 3I Atlas passed closest to the Sun on October 29, 2025. During that time, it was hidden behind the Sun from Earth's point of view. X-ray telescopes can't look too close to the Sun because the glare overwhelms their instruments. They need objects to be at least 60 degrees away from the Sun in the sky. XRISM had to wait. By late November, 3I Atlas had moved far enough away from the Sun's glare to be observed safely. The XRISM team released their findings on December 3, 2025, through the Astronomer's Telegram, a system scientists use to quickly share new discoveries. Here's what the data shows. The X-ray glow is diffuse, meaning it's spread out rather than concentrated in one spot. It forms an elongated cloud centered on the comet's nucleus, the solid icy core. The team carefully cleaned the data. They removed detector noise. They corrected for the comet's motion across the sky. And after all of that, the glow was still there. Real. Confirmed. They also examined the X-ray spectrum, which breaks the light down by energy. It showed emission lines from carbon, nitrogen, and oxygen, elements known to be present in the comet's gas. That confirms the X-rays are coming from 3I Atlas itself, not from some background source. That said, the scientists are being careful. Telescopes can sometimes produce false signals from things like detector noise or image darkening at the edges. So, while they're confident in the detection, they're continuing to analyze the data before making final conclusions. That's exactly how science should work. Now, let's talk about why 3I Atlas already stands out. It's only the third confirmed interstellar object humanity has ever observed. Oumuamua in 2017, Borisov in 2019, and now 3I Atlas in 2025. But this one is different. Totally different. It's larger. It's way more active, not really fitting the pattern of normal comet behavior. It has a tail. It releases gas. It brightens as it approaches the sun. The X-ray detection confirms something important. Interstellar comets respond to the sun in very similar ways to comets from our own solar system. The chemistry may differ. The ratios of elements may be unusual, but the basic physics is the same. That suggests the environment where 3I Atlas formed isn't completely alien compared to our own. Now here's another strange detail. The X-ray halo around 3I Atlas is much larger than what we usually see around comets in our solar system. Most local comets show X-rays limited to their inner coma. 3I Atlas has a glow stretching hundreds of thousands of kilometers.
Why?
One idea is that it's releasing more gas than typical comets, creating a much larger area for the solar wind to interact with. Another possibility is its speed and trajectory. It's moving fast, on a path that will take it out of our solar system forever. That may affect how the gas spreads out. Right now, scientists don't know for sure. They're still working through the data. At this point, 3I Atlas is moving away from the sun. It passed perihelion on October 29th, but on December 19th, 2025, it will reach its closest point to Earth. That's just 5 days away. It'll be about 269 million kilometers from us. Yes, that's still far away from Earth, but close enough for extremely detailed observations. The James Webb Space Telescope is planning more observations this month. Hubble continues to monitor it. Ground-based telescopes are tracking it as it moves through the constellation Leo. Meanwhile, the XRISM team plans to keep refining their analysis, mapping the shape of the X-ray emission and measuring its intensity more precisely. All of this matters for the future. As telescope technology improves, we're going to find more interstellar visitors. The Vera Rubin Observatory in Chile is coming online now, scanning the entire sky every few nights. Scientists expect we'll soon be detecting smaller and fainter interstellar objects far more often. Each one will teach us something new about other planetary systems, how comets and asteroids form around different stars, and how diverse our galaxy really is. 3I Atlas is showing us the way. So let's recap. Japan's XRISM telescope detected X-rays from interstellar comet 3I Atlas, marking the first X-ray detection from any interstellar object. The X-ray glow extends about 250,000 miles from the comet's center. The emission comes from charge exchange, where the solar wind interacts with gas in the comet's coma. And scientists are still analyzing the data to understand exactly why this comet behaves the way it does. Tomorrow, we're going further. We'll talk about what the upcoming December 19th close approach could reveal, what scientists are hoping to see, and why the next observations might change how we think about visitors from other star systems. Make sure you're subscribed and notifications are on. Thanks for spending this time with me. And I'll see you tomorrow in my story corner for the newest data update.